Hi everyone. Today I'm going to be introducing to you the normal distribution, and more specifically, I'm going to introduce you something called the Z-score. Now, I'm going to show you what a normal distribution looks like. A normal distribution is this curve here, where it's like a bell-shaped curve. Now, the center point here, we call it having a mean. We call this the mean, okay? So I'll just put X with the bar on top. I'm not sure if you're familiar with the notations. I did mention some of these when we were doing some statistics, but X with the bar on top, that's the notation for mean. So this center point is always referring to the mean. Now, remember standard deviation, guys? Standard deviation gives us a spread of the scores. So a bigger standard deviation means that it's more further away from the mean, isn't it? So here, I've just put some bars down here so we can try to evenly spread out the normal distribution. And going one to the right, one to the left. That means one standard deviation above, one standard deviation below. Now underneath it, I put some of these Z-scores. Don't worry too much for the formula yet. I'll explain to you how we get that one, but let's just worry about the normal distribution for now. So as you can see, a mean is the center point. In that case, it's not anywhere, it's just exactly on the mean, right? That means the Z-score is simply 0 because it's on the spot on the mean. But if it's one standard deviation above the mean, we call it having a Z-score of +1. If it's one standard deviation below the mean, we call it having a Z-score of -1. Make sense, guys? It's nothing hard. It's very, very simple. So as you can see, this is 2 plus 3 plus 4. It indicates how many standard deviations above or below the mean the point is. So this one is just going down, right? So the bigger Z-score means it's more further away from the mean, okay, in the integer value. So have a look. I'm going to introduce to you this formula for the Z-score. The Z-score, we just call it Z, equals to score. So the score of whatever data you're looking at, minus the mean of that data set, the whole thing over the standard deviation of the data set. So in formula wise, X, we always let it be the score or the point or the data, whatever you want to call it. X is a score, minus X with the bar on top is our mean, isn't it? We always subtract the mean from the score and then we divide the whole thing by the standard deviation, which I'll just call S. Makes sense, guys? So just remember, guys, the middle point here is the mean, and we're going to examine how many points away from the mean the particular score is. Makes sense, guys? So trying to get really familiar with that formula there. So starting with question 1, it tells us that the mean is 68 and the standard deviation is 10. So they actually indicate to us what the mean and the standard deviation is, right? And they say, find the Z-score of 88. So in this case, when they say find the Z-score of 88, it means find the score of the score 88. So 88 is the score, okay? Now, we want to find the Z-score so we can examine how many standard deviations away from the mean that particular point is. We want to know that situation, the positioning of that score. So remember our formula. I'll just keep it up here so you can try to be more familiar with. Z-score is simply the score minus the mean over the standard deviation. So we've got our score, which is 88. We've got our mean, which is 68, and we've got our standard deviation, which is 10. So we just put it all into the formula just like that. So score minus the mean over the standard deviation 10. And just calculate it. You can use a calculator if you want. Shouldn't be too hard. It's simply 2. So what does 2 indicate, guys? It simply indicates that it's 2 standard deviations above the mean. Make sense? Let's try another one. Find the Z-score of 68. So in this case, 68 is the score, and we want to know the positioning of that score in terms of the mean on the normal distribution curve. So put it into the formula again. This time our X is going to be 68. That's the score. So I put it like this. So 68 is the score for X. So put 68 there, and we minus the mean. The mean is also 68, and then we again divide it by our standard deviation of 10. Now guys, 68 minus 68 is 0. 0 divided by anything is 0, so our Z-score is 0. Now can you guys indicate to me what the 0 means? The 0 means that there's no standard deviations above or below the mean. It's exactly on the mean. So we can say that Z-score of 0 indicates it's exactly on the mean. And we know that because 68 is exactly the same as the mean. So somehow you can kind of relate that. Now C, we'll do one more. Find the z-score of 58. So I'm going to put 58 into my score x. So 58 minus our mean of 68 over the standard deviation. Calculate it, you should get a negative number, a -1 in this case. Now -1 indicates that it's one standard deviation below the mean because it's negative. So make sure you concentrate on whether it's positive or negative. Now question 2, it says find the score that corresponds to the z-score of 3, the mean of 45 and the standard deviation of 5. So it says find the score. So we don't know what the score is. We don't know what x is. Remember how x is a score? And it tells us that the z-score is 3. So this time they actually give you the z-score. It's 3. The mean is 45, that's what we'll put there, and the standard deviation is 5. So let's just put everything into the formula. Everything that we have, I'm just going to fit it into the formula just like that. So the score we don't have, so we'll just call it the x minus the mean of 45, the whole thing over the standard deviation of 5, and they tell us the z-score. It's equal to 3, so we can let the expression be equal to 3. Now we have one pronumeral that we don't know, which is the score, x. So let's go and solve for that using our algebra. So we're dividing by 5, so if we simply multiply by 5 to the other side, don't we? And 3 times 5 is 15. So if x minus 45 is 15, what do I have to do to the negative 45? We have to add 45 to 15 and get 60. So we can say that the score is 60. That's all you need to say, all right? That's the x that we've just found. That gives us a z-score of 3. Question 3, find the mean that corresponds to the z-score of 4, the score of 50 and the standard deviation of 5. So this time they give us what the z-score is. They also give us the score, which is for 50. Score will just be x. And they also give us standard deviation, which is 5, which is s. Now they don't give us the mean, and that's what we want to find, isn't it? Because it says find the mean that corresponds. So again, the mean, x with the bar on top, will be left unknown, but everything else we can put it into the formula like this. So the score is 50 minus the mean, which is x with the bar on top. We don't know what that is, so we'll find that, over the standard deviation of 5, and it tells us that the z-score is equal to 4. So again, we're dividing by 5, so let's go ahead and move it over to this side by multiplying by 5. 4 times 5 is 20. So if 50 minus x with the bar on top is 20, we can simply subtract 50, isn't it? So that's positive 50. Move it over to the other side by subtracting, and on the left-hand side we still have negative x with the bar on top left. 20 minus 50 is negative 30, isn't it? So negative x bar equals to negative 30. If it's negative on both sides, we can just get rid of the negatives, and x with the bar on top, which is the mean, will be equal to 30. So the mean is simply 30. This mean indicates to us that using the score and this standard deviation, the z-score will become 4 using our formula. Okay, so this is the formula you're really going to be familiar with. That's the z-score formula.